Hey T, ooh, breakfast.
No, Liv. Science.
Oh, okay, well, are you doing food science?
Well, yes. I'm making a chemical reaction.
Oh, how?
Well, Well, I think because I poured this hot water into this bowl, it changed the chemistry of the oatmeal.
How?
Because, well, okay, you got me there, Liv. I thought a chemical reaction was just when you put something in another thing and it makes it different than it was before.
Not exactly, T. Actually, I think our friend Kaitlyn will be able to explain this best.
Hi T, hi Liv.
Hi, Kaitlyn.
So I heard you two were having trouble with chemical reactions.
Yeah, I'll be the first to admit that I thought a chemical reaction was when one thing becomes another.
You should be the first to admit it. You said it.
Haha! I guess I did. Huh.
You did.
Okay, well, let's explain what a chemical reaction is. A chemical reaction is a process where a set of substances undergo a change to create a completely new, different substance. A chemical change is when something changes all the way down to the smallest level. When a substance is changed chemically, it can't go back to the way it was before.
Oh, okay. So pouring water into oatmeal isn't exactly a chemical reaction.
Nope, it's still oatmeal, it's just absorbed water now. That would be a physical change.
And just so we're clear, what is a physical change?
Well, a physical change is when something changes in color, texture, shape, or state. These are changes in matter that don't change the matter itself. And matter is anything that has weight and takes up space. That means that physical changes do not make a new substance.
So a physical change is when something changes, but not in the way that makes it completely different.
And a chemical change is when something becomes a new substance, like that time that we made slime together.
Exactly.
We made our own physical changes.
We did?
Yeah, when we made those tree rings, we changed the shape of the multicolored clay.
Oh yeah, we did. We made the clay go from a lumpy blob to some worms.
To a cool, fantastic looking ring.
Exactly.
Yeah.
Good job on understanding the difference between chemical changes and physical changes. When we do science, it's important to be careful with our words. We have to be accurate and precise.
What do the words accurate and precise mean, Kaitlyn?
Great question. Accuracy is how close a measurement is to the actual value you're trying to measure, and precision is how close a measurement is to other measurements you've made. So if you weigh a 5-pound weight 3 times and get exactly 4 pounds every time, that measurement is not accurate, but it is precise. And if you weigh that dumbbell and you get 4.5, 5, and 5.5, that is not accurate, but it is precise.
I know a way we can be accurate and precise.
With our experiment!
Exactly. Let's go try something out.
See you later, Kaitlyn.
Bye.
Hey, Liv.
Hey.
Looks like we've got some exciting experiments for today.
Absolutely. What do we have for materials today?
All right, so for materials, we have a paper towel.
Keep it clean.
Yes, we have a graduated cylinder. We have a beaker, 2 plastic pipettes, and some water.
Oh, amazing. And just so I know, what's the difference between a graduated cylinder and a beaker?
Well, a graduated cylinder is made specifically for measuring liquids, which remember is important for accuracy. Cylinders have a much smaller margin of error than beakers do, and this helps us see the smaller differences in amounts of liquids that we're measuring, which in turn helps us be precise. But the thing is, beakers are still important because they can be used to measure or mix things. But they aren't as precise as graduated cylinders.
Oh, okay. Now I get it. So, T, what's our experiment today?
Let's practice using our pipettes.
And how are we gonna do that, T?
Well, let me show you. First, I'm going to grab our water and pour about 50 milliliters of it into this beaker.
Cool.
So, a cool trick is to look at it from the side to see how accurate you can be.
Oh yeah, boom.
Cool.
I got a little over, that's okay.
Next, we're gonna take this pipette and squeeze it at the top. It's really important that we squeeze it at the top because we want to make sure that there's no air bubbles in our pipette before we grab our water.
Hey young scientists, so this is what we're going to do today. We're going to get a clean pipette and we're going to squeeze it here at the top. Make sure there's no air bubbles, and there you have it. Now, let's watch Liv and I do it in real time.
And look at it all. Oh, some air bubbles got in there. Sometimes it's gonna happen.
Oh, but they all float to the top, it looks like.
They do float to the top. So we're gonna take this pipette and put it into our graduated cylinder.
Oh, cool. And it's also cool how the pipette has little measurements on it too.
Yes.
So we know all the way around how many milliliters we're collecting.
Exactly. So I'm gonna do this a couple of more times.
Alrighty. Careful, that's why we have the paper towels.
That's exactly why we have paper towels. All right, so we should at this point have about 15 to about 25 milliliters of water in our graduated cylinder. So, but yeah, we have
Cool, looks like you're done, T. And it looks like we hit about, I'd say close to 17 milliliters, which is exactly accurate.
Oh, isn't science awesome?
It is. Can I give it a go?
Yeah, of course. Let me just pour this water back into our beaker.
Alrighty.
And you give it your own try.
Alrighty, so I'm gonna squeeze it nice and tight, let it all fill up, and then a transfer.
Wow.
This is so fun.
Oh yeah.
Oh, got some air that time. I feel like if I pull it out before fully letting it all absorb up the pipette, that's when the air bubbles come. There we go, cool. That looks like I got to about maybe 15. I think you might have done one more than me.
Well, good job, Liv.
Thank you.
Yeah. All right, next up, we're going to see Kaitlyn's lab, and she's gonna show us her own chemical reaction.
No way, can't wait.
All right, let's go check it out.
Hi, I'm Dr. Kaitlyn Webster, and today I'll be showing you a chemical reaction where we make plastic out of milk. So we're going to start with milk, and we're not going to end up with milk. We're going to change it into a totally new substance. So I'm pouring about a cup of milk, 100 milliliters, into a beaker, and we're turning the temperature up so this plate is warm, and it's going to heat up the milk. So that's our first step. So this is a nice solution. The milk is all just one thing. It's fat and proteins and lots of vitamins and minerals. And we're going to take one of those, which is called casein, and remove it from the solution and turn it into a clay. So now that I have my safety goggles on and the milk is warm, we're going to add some acetic acid, aka vinegar, which will change the pH of the milk so that we can do our chemical reaction. So we'll add a little bit and keep it stirring. So there's a magnetic stir bar in there. We're going to add about 4 tablespoons. You can see something is changing in there. We used to have this nice uniform milky solution, and now we have some stuff in there. So what is that stuff? We're going to give it a little bit more of a stir, and then we're going to see what comes out. So you might notice there's white stuff in there. There's also yellow stuff in there. It's not the milk that we started with. So we bring this over to the sink and see what happens. That sure isn't the milk that we started with, is it? All of this globby white stuff was part of the milk, but Adding the acetic acid caused a chemical reaction that turned it into casein, which is a polymer, which is a bunch of single molecules that came together and made big, large ropes. So notice it kind of looks like clay, kind of looks like cheese, but it's certainly not milk anymore because of the chemical reaction we did. And all we had to do was add heat and acetic acid.
Kaitlyn, our experiment was a success.
Fantastic work, young scientists. It's always thrilling to witness the magic of chemical reactions. You two made some great observations. Precision and accuracy in experiments are crucial. You're doing excellent work.
Thanks, Kaitlyn. We're ready for our next adventure.
What's in store for next week?
Well, next time we're gonna dive into the world of glittery centrifuges and how centrifuges work.
Glittery centrifuge. That sounds intriguing.
Very intriguing. I can't wait to dive into our next glittery adventure.
Until next time, keep that scientific curiosity burning bright, young scientists. Bye! All right, so how many did you do, Liv? So I do the same amount?
Yes.